clockwise. Of course, we'll say up and down. All right, so you can put 2 electrons in energy level 1. Okay, energy level 2 is 4 times bigger. So we can put 4 times as many. So how many can we put there? We can put 8. Okay, energy level 3 is 9 times as big as number 1. So how many can you put in there? 18. All right, energy level 4. 16 times bigger than energy level 1. So you can put 32. Energy level 5, which I don't have up here, but we can figure it out. 25 times bigger than energy level 1. So you can put 25 times 2, or 50. Can you figure this one out? Energy level 10. How many electrons can go in it? The energy total number of electrons, maximum. That's, by the way, that's maximum number. 200, okay? So it's going to be 10, be the radius. 10 squared pi is 100, and then 2 times 200. Okay. So the maximum number of electrons in energy level is equal to the energy level squared times 2. That's pretty cool. Okay. It's you know, so if it just works out that way, all right. So I'm gonna redraw this. So energy level 1 can have 2 electrons. Energy level 2 can have 4 electrons, 8. Energy level 3 can have 18. Energy level 4 can have 32. Okay. All right. Okay, now what we're going to do is we're going to put the shapes in this thing. Okay, so I hope this makes sense. Is every time you get an energy, it gets bigger. Therefore, you can put more things in it because it's bigger. Okay, so now let's see how the shapes work, the probability spaces. Okay, energy level 1 is the most likely place where an electron will be. So if you throw an electron somewhere up at this guy, it's going to try to go here. Why is that? Because that's the lowest energy. Okay, it wants to reduce its energy, and the way it reduces its energy is by getting close to the protons. So electrons always want to move as close as they can to protons because that releases their energy and makes them feel more calm, more ease, okay, less stressed. When you take an electron and move it out, okay, it requires energy to do that. Why does it require energy? Because it wants to be up here, okay? And so these guys out here have higher energy than they do here. Okay. So energy level 1 is the most probable place for an electron be. You can put 2 of them in there. Let's see where they go. Well, the most basic shape is an S shape. All right. That's what this guy has. This guy has just an S shape. It has an S orbital inside an S subshell. And in each one of this, in each orbital, you can put 2 electrons. Okay, so you put 2 here. Okay, so there's the S. Okay, energy level 2 is bigger. And what it can have is an S. All right, it can be the shape of S, but also it can turn into a P shape as well. Okay, so It has an S, but also it can turn into a P shape. Okay, and I'm just going to use squares. So this whole thing's the subshell, and these are the orbitals inside it. Okay. So what happens is that energy level 2 can fluctuate between an S shape and a P shape. All right. So most of the times it's S, but if you give it a little bit of energy, it also turns into these lobes. Okay. All right. So it fluctuates between these shapes. All right. So this. Okay. Energy level 3 is bigger, so you can put S shapes, P shapes, and also Ds. Okay. All right, energy level 4 is bigger, so now you can put S, P, Ds, and S. There's your S, the P subshell, your D subshell. Now, S subshell, okay. And I just draw them like this, but you can imagine, hopefully you can imagine is that this guy, what it can do is sometimes it's a sphere, but sometimes it can fluctuate and turn into one of these guys. Given if there's a certain amount of energy, it can fluctuate into those. Okay. The energy allows these guys, because these electrons out here have a lot of energy, it allows them to fluctuate into different probabilities. Okay. This guy down here has such a low energy, it just fluctuates, just stays in S. This guy here has a little bit more energy, and so it can fluctuate between an S and a P, and so forth. So, all right. Okay. All right. So let's take a look at this. All right. So in each orbital, you can put 2 electrons. They can pair up. All right. So if we look at this, so in energy level 1, it has only S subshell and 1 S orbital, and you can put 2 electrons. So how many electrons can you put in energy level 1? 2. There's 2 inside that guy right there. Okay. Well, that's what we predicted. Okay. We predicted that there would be 2. And where are they? They're in a S subshell. Okay. Energy level 2. It has this orbital. You put 2. Has 2, 2, and 2. So how many can you put here? 2, 4, 6, 8. You can put 2 in the S and 3, 6 in the P. How many is that? 8. And that's what we predicted. Okay. All right, energy level 3. You can put 2 here, 2 in each one of the orbitals and P. And this is the maximum number of electrons. And then you can put 2 in here, and you add them up, you get 2, 4, 6, 8, 10, 12, 14, 15, 18. Well, that's what we predicted, okay? 18. Pretty cool. Okay. Okay, next one. 2, 2, 2, 2. 2, 2, 2, 2, 2, 2, 2, 2, 2. And when you add them all up, total 32. Okay. So we know that the how many electrons will go in each energy level, but they all don't go in equally. Some will go, the first few will go into S, then the next will go in P, the next will go in D, and so, and each one is a little bit higher energy level, energy situation. Okay. So, okay, let's talk about subshells here. Number of subshells and energy level. Let's just take a look at that. So what we want to do is see if there's a formula to figure out how many subshells are in each energy level. Well, there is. How many subshells are in energy level 1? 1. How many are in energy level 2? Be careful. How many subshells are in energy level 2? 1, 2. Okay. These are orbitals, and the orbitals are in the subshell. Okay. So energy level has how many subshells? 1, 2, 3. Okay. The subshells are made out of orbitals. So there's orbitals inside the subshells. All right, energy level 4 has how many? 1, 2, 3, 4. So how many subshells there are in energy level? Well, whatever energy level you're in. So if you have energy level 10, how many subshells will there be? 10. That's pretty cool. All right, the other thing is the number of orbitals in an energy level is basically it's just the energy level squared. Okay. Energy level 2 has how many? 1, 2, 3, 4. It's 2 squared. Energy level 3 has 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 3 squared. So if you know the energy level, you know a lot of stuff. You know how the maximum number of electrons. You can figure out how many subshells, and you can also figure out the number of orbitals. Okay. All right. Okay. This is not a model of the atom. This is what I might call the Russian doll. Okay. Do you know what I'm talking about? Russian dolls? There's those nesting things. Is that you open it up and there's a mama, and then you open it up and there's a daughter, and then they open it up and then another little daughter, and then open up, and then finally get down to a little baby. That's what this is. Okay. So here's your atom. Okay. And what you can do is you can split your atom up into energy levels. Okay. And we'll see how that, when we look at the atoms, we'll see that. All right. So technically, every single atom is going to be situated like this, and we'll put it all together in a minute. In the energy levels, there's subshells. Okay, so here's the energy level, and it has subshells. And inside the subshells, there's orbitals. Okay, and what are in the orbitals? Electrons. And what the electrons have is they have spin. Okay, so that's the way to nest it. So you have your atoms, then you can break that apart, you can split it up into energy levels, and then you can split those up into subshells, then you can split the subshells up into orbitals, and then inside the orbitals are the electrons, and those electrons have spin. Okay. All right.
What are spins?
Spins, what I talked about is that it's the counterclockwise is each electron has a spin. It's either going to be, what we say is it has counterclockwise or up, or the other way, counterclockwise and down. And there's always pairs. That's why you can put 2 electrons in each one of these orbitals, is because if you put one in, you can put in its pair as well. All right, what I'm going to do is I can clean this up. I don't want to draw circles anymore, at least not now. And I want to demonstrate this using another method. All right, orbital energy diagram. It's another way to describe this. It'll make it a little bit cleaner and show us what we need. So we're not going to think it's about we're not going to think about electrons going around around an atom, around the nucleus. We're just going to say they have different energy levels. And we know that the energy levels are different, and they're quantized. There's 1, 2, 3, 4, okay? And in each energy level, there's going to be subshells. Then what that means is different shapes that the electrons can, the probability spaces that the electrons can be in. And then more specifically, those subshells have, the shapes are more defined as orbitals. Okay, so it's kind of a graph. So over here we're going to have energy level. Okay, and down here are subshells. So S, P, D, F, and so forth. There's an infinite number of subshells, just like there's an infinite number of energy levels. Really, we won't go out there. We won't have that infinite amount. But we'll just focus on the first few subshells and energy levels. Okay, so energy level 1. There's only one of them. I mean, there's only one shape, one subshell, and that one subshell has an s orbital. Okay, so I'm just going to draw one square to represent both the subshell and the orbital. Okay, energy level 2 can have an s orbital, s subshell, but it also can have a p subshell, and that p subshell can be split apart into 3 parts. So each one of these is an orbital where the electron would say resides, but that's just making it so we can understand. Okay, energy level 3 has S. It also has P's, and then it has D's. Okay. So you can put so electron in energy level 3 can be found in an S, and found in a P or a D subshell. Energy level 1 it only can found in an S because it's so small and has low energy. Energy 4 is as high as I go. All right. Okay, so instead of drawing that circle, I have all the same information here. So energy level 1, you can put 2 electrons. It has a 1 subshell. Energy level 2 has 2 subshells, an S and a P. You can put 2, 4, 6, 8. Energy level 3 has 3 subshells, S, P, and D. Put 2 here, 2 in each of the P's, so you get 6, and then 2 in each. There, 5 is 18. Okay. So what we have here is we have, this is an electronic structure. Okay. So the orbital energy diagram gives an electronic structure of the atom. Okay, some things about this, the way it's made. All right. It also helps us think about visually what's going on. What we're going to do is, so what we're going to say is, right now, let's say I had an atom with 4 energy levels. This is the outer layer. Okay, so this is the outside. This is the inside of the atom. So if we were to draw it in terms of a circle, this would be inside and this would be on the outside. So with the highest energy level, next to that is the inside and the outside world. All right, that's important. The other thing is that you'll see in a second, I'm going to put a big plus down here to represent protons. And that's because what we want to do is we want to start putting electrons in here. And what's going to happen is the electrons can live in each one of these squares, but they're not just gonna be random, willy-nilly falling, looking for an open spot. What they're gonna always try to do is find the lowest energy. The lowest energy on this diagram is down here, energy level 1, next to the protons. So the electrons are always going to want to go down. The other thing is they're always going to want to head toward the S, because the S is the most probable probability space. Okay, so electrons are always going to sort of lean this way, like lean down like this. They're going to lean towards energy level 1 and towards S. That's naturally what they're going to do. Okay. All right. Okay. This is what we're going to do now. Is we're going to start dropping the electrons in, and it'll end up predicting how the electrons fall into each of the atoms, where they're located in atoms. All right. So I'm just going to start dropping electrons in. I'm not going to talk about a particular atom. All we're going to do is go through the process of how the electrons fall into this diagram. So to visualize what I do is I'm going to have an electronocopter. Right. So I'm going to have a helicopter. Okay, and what he's going to do, he's going to carry electrons. Okay, and what he's going to do is he's going to drop it in. All right, and what that electron is allowed to do is allowed to explore every one of the orbitals. And what it wants to do is it wants to find the lowest energy that it can go into. So you drop it in there. And what it does is it starts to go to lower energy. So it goes over here, and then it comes down, and it keeps looking, and it gets right here, and it looks down here, and goes, there's no one in there. And it's really low, close to the proton. So what does it do? It goes in there. Okay, so we put an electron in here. So if you just have one electron, that one electron will fall all the way to the bottom. Okay, it'll fall into the 1s, and it has a spin. And just for convention, I'm gonna put up arrow first. Up arrow means up spin. Okay, I could have made it down, but it doesn't matter. All right. Okay, drop the next one in. So let's say I drop another one, comes in, blah 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 blah. Okay, this one comes up here, it's right here, and goes, well, I can stay up here. It looks down here and goes, you know what? I could go down here, but what I have to do is make sure that I'm down spin, okay? So if it's up, it'll flip, okay? So it goes down here. If you put another up there, that up has already been taken. You can't have two ups together. You can have two downs together, but you can have an up and a down. All right. Next electron comes in, blue, 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 comes in, and it goes, it's right here, and it looks down here, and you can't go there, because in an orbital there can only be one up and one down. Okay, because if you put another up in there, that means is that, well, you can't have two things taking up the same space. So you can't have two electrons taking up same space. Okay, so if I put it up there, well, it's already taken up, so it can't be there. Okay, put it down, it can't be there. So this is actually given, it's called Pauli's exclusion principle. Okay, Wolfgang Pauli came up with it. He was one of the guys that was working on the model. So where does the third one go? It has to go up here. And again, I'm just out of convention, I have it spinning up. All right, third one, fourth one, let's say I have 4 electrons. First one go here, second one go here, third one go here. Fourth one's gonna go right next to it, okay? Because it's in the S. It doesn't want to go to the P's because S is lower than P. Okay, if I had a 5th electron, where's that gonna go? 1, 2, 3, 4. So the 5th one is gonna go right here. Okay, again, I'm just using up. Okay, all right. So I have 5 electrons, and now I'm gonna put in the 6th electron. Now the 6th electron has an option. Okay, so the 6th one comes in. It has an option to pair up with this guy or to go to one of these two. Okay, why can it go to one of these two? Because these two are exactly the same as this one right here. The way I kind of think about it is if you go to a hotel with your friend and there's 2 beds, I think you're probably going to both sleep in a different bed. That's friends, okay? So where's the next one go? It goes right here. And I'm just having it go up because up is convention for the first one. Okay. And so that actually is lower energy because this put in right here, they're both negative and they're going to be kind of repelling each other. So this guy moves out here instead. All right, if you had another electron, it would go here. Okay. And then when you have 1, 2, 3, 4, 5, 6, 7, an 8th electron is not going to go up here, has nowhere to go. What it's going to do is pair. Okay, and that's called some rule. I forget the name of the rule. I'll come up with it in somebody's rule. Oh well. Okay. But that's what happens. Okay, so then the next one, if you had another electron, it would go here, another electron here, and then you would go back up. Okay. And so what you do is you just, as you keep on electrons, you keep on going through the same process. So, I don't know, let's say I have 19 electrons. Let's say I have 19 electrons, I'm going to drop them all in. So I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay? Now the 19th electron, you might think it goes here, but actually it goes up here. Okay? And why it does that? Well, I don't want to get into it. It has to do with this is a little bit lower energy than this subshell. Okay? And one higher energy level up, S, is lower than a P, so it ends up there. So what I'm going to do is I don't want to go into that. And it's easy to figure out the patterns for all that stuff. I just want to stop right here. For this model, all we're going to worry about is having a maximum of 8 electrons. So I'm just going to stop right there. You can keep building, but there's different rules and things actually start falling apart. This model is not perfect. It starts really falling apart. The bigger the atom is, okay, the more electrons you have, they don't do what you expect them to do. Okay. Okay. Now what we're going to do is we're going to actually apply this to atoms. So we're going to use this to figure out the electronic structure for atoms. And we're just going to do the first 18 elements up through argon. And we're going to use the same process. Okay. All right, now there's more out here, but I'm going to leave them off. Okay, I'm just going to deal with the first three levels. And there's D's over there, but I'm gonna leave them all because that's what I said it. All right. So I'm gonna just do a couple of these and then we'll do practice. Well, let's start out with hydrogen. Hydrogen has one electron. Okay, where does that electron go? Goes right here. So the orbital energy diagram for hydrogen is that. Okay. Just one electron pointing up. You could have it pointing down, but just one electron and then one s. Okay, so let's be more complicated. Let's try fluorine. Okay, how many electrons does fluorine have in its ground state? 9, okay. So number of protons, which is the top number, not atomic number. The number of electrons is usually, especially when it's in the ground state, is the same number as protons. Okay, so I had 9 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. All right. Okay, so here you guys try a couple. Okay, beryllium. Chlorine. And magnesium. The orbital energy diagram for those 4. This process is called the off-ball principle. The word off-ball is German for build. Okay, so we're building the electronic structure of an atom.